Today we continue our introduction to the anisotropic medium. And isotropic medium. We consider the electromagnetic wave propagating in anisotropic medium. When I say anisotropic medium, I mean that the medium has some specific direction. If you apply the electric field, then along some direction it is easier to polarize this medium. Along different direction, it may be harder to polarize the same medium. OK， 就是说有一个介质，假设你加电场，介质就被极化。但这种介质呢，如果极化的难易程度跟方向有关，这就是所谓的各项异性介质或者非等向性介质。那这个非等向性介质里面的光的传播行为会跟等向性的有差异So wave electromagnetic wave propagating anisotropic medium, the behavior of the electromagnetic wave will be more complicated when compared to the isotropic medium. Okay, isotropic medium means that something, for example, glass, air, water, etc. Anisotropic medium means that, for example, the calcite, the NaCl or some crystals, 就一些其他的这个晶体晶体因为它有一些特殊的原子排列方向，所以你加电场给它的时候呢，它沿着某些轴它比较容易极化，沿着另外一些轴可能会比较不容易极化它在不同的方向上有差别那这种的介质就叫做 anisotropic 介质。那 anisotropic 介质的这个电磁波的行为会比 isotropic 介质复杂一些，所以我们的第4章主要就在研究这种比较复杂的一些现象。OK， 好。So for describing the wave propagating in anisotropic medium, first we know that the related physical quantity is the so-called polarization. This quantity is called electric polarization. 叫电极化，电极化、极化，或者叫做极化向量。The same terminology polarization will be used in different sense. Okay, in chapter 3 and in chapter 5, we say polarization. This word means that the direction of the electric field. However, here we use this terminology polarization. It means this quantity. This quantity is defined as the dipole dipole moment per unit volume, or you may say it is dipole density. Dipole density or dipole moment per unit volume is this so-called polarization. And according to electrodynamics, we have a quantity called displacement field, D, electric displacement, which we have already introduced in chapter 1. D is related to E and P. By this relation, the electric displacement is written as epsilon 0 times E plus P. Here E is the electric field in the medium. And since I say that in an anisotropic medium, it may be more easier to polarize the medium along some direction, but harder in other directions. So, for example, suppose we have two specific directions. This may denote as x direction, this y direction. And suppose if we apply E field along the x direction, we get Px is equal to epsilon 0 times chi x times Ex. And when we apply electric field along the y direction, we get Py is equal to chi y times Ey. Okay. When I apply electric field along the x direction, I get this relation. When I apply the electric field along the y direction, I get this relation. This coefficient called susceptibility. If chi x is not equal to chi y, this is the general feature we encountered in anisotropic medium. Then, for example, if I apply electric field along this direction, I can project the E field to the x-axis and the y-axis. So I get Ex, I get Ey, and since chi x and chi y are different, so Px is not proportional to Py. So finally, 假设这个是 x， 这是 x 轴，这是 x 轴，这是 y 轴。好，那假如说，比如说啦哈，它大于它 ，OK， 好，那这时候这边就长一点，这边就长，这边就短一点，所以我就会得到一个这样子。这样的 P 的话呢，这样。So in general, I will get the result that P is not proportional to E. Okay? So in anisotropic medium, since along different direction, the polarization, the ratio between Py and Px in general is not equal to Ey to Ex. So in general, P is not parallel to E. Since P is not in general not parallel to E, we can also obtain the result that D is in general not parallel to E. 所以就是说，一般来说 ，in general D is not parallel to E。就一般来说，在 anisotropic linear 里面，如果你加电场在任意方向上 ，D 和 E 的方向是不一样。Only along certain specific directions that you get D parallel to D is parallel to E. In general, you will not get this result. In general, you just get D is not parallel to E. 所以在 anisotropic 介词里面 ，D 跟 E 不平行。However, the relation between D and E is a linear relation 就是说如果我们考虑的不是 nonlinear optics 的话，那它们是 linear relation If we are not considering the nonlinear optics, although D is not parallel to E, the relations between them are still linear 就是 D 和 E 还是有一个所谓的线性关系那这线性关系的意思就是说，它们之间可以透过一个矩阵联系起来So remember that in electrodynamics, we usually can write this result as epsilon times E. Okay? In isotropic medium, the epsilon is very simple. It's just the coefficient called permittivity. If we want to keep the relation between D and E looks like the original form, then we must generalize the idea of epsilon to a tensor. Okay? So now we have this relation between D and E. So in general, in anisotropic medium, we can write the relation between D and E as this. Okay. Here, this is called permittivity tensor. Ah, 这个就介电这叫电容率或者叫介电场数哈，介电场数或电容率。那这里也是一样啊 ，similarly。There is a relation between P and E. This is also a linear relation. So if I write these two equations in component form, I can write this as di is equal to summation j epsilon ij ej, and the p I is epsilon 0 summation j chi ij ej, which means that I can write them in the matrix form. D x d y d z is related to e x e y and e z by this equation. Here we have epsilon xx, epsilon xy, epsilon xz, epsilon yx, yy, yz, zx, zy, zz. Okay. Similarly, the p vector is related to E by this equation. Px, Py, Pz, chi xx, chi xy, chi xz, chi yx, chi yy, chi yz, chi zx, chi zy, chi zz. Okay, so in general, we have these two linear relations. Okay. So, what is epsilon ij? Okay, since we have D is epsilon times E, and originally we have epsilon 0 times E plus P. Okay, and then you can substitute this relation here. Epsilon 0 times identity matrix plus chi matrix dot E。OK， 好，这个东西呢，这个 I 的意思就是单位矩阵啊。Here I is the它是一个这个就是不改变任何东西的张量的啊，那它的矩阵表达式就是单位矩阵啊。好，我们基本上是这样，就是说这些关系式本来的是这样写的时候啊，它们是跟你选哪个坐标系无关的，啊，但是你究竟会得到什么分量，会跟你选哪个坐标系有关，啊，these relations are in fact coordinate independent, okay. However, if you want to find the components, I want to know why is dx, why is dy, why is dz, you must choose a coordinate system. So you will get the three components, okay? And similarly, once you choose a coordinate system, you get the matrix form of this epsilon and this chi, okay? So this quantity, this so-called tensor quantity, is in fact coordinate independent. But you can represent them as matrix. The matrix component are determined by the coordinate system you choose. OK， 好，你选了什么样的坐标系统？会决定这些分量是什么，但不管你选哪个坐标系统，这个形式都不变。好 ，No matter what coordinate system you choose, the relation between D and E is always this form. Okay, and the relation between P and E is always follow this form. So suppose I choose a coordinate system and I find that I can write the D as column vector D And I have this relation here. D is a column vector. This is also a column vector. And this is a square matrix. If I do the so-called coordinate transformation, I will change the components of them, but the form is the same. 所以我们做坐标转换的时候呢，这些分量都会变，dx、dy、dz、ex、ey、ez 都会变。那 epsilon 的分量也要跟着变，但是这个关系是维持不变的。这关系维持不变。Tensor equation 的特性就是这样。The tensor equations had the property that you can change coordinate system, but keep the formula the same form. Okay, the coordinate system will determine the components, but the form is not altered. 这个方程式的形式不会改变。Okay, so a coordinate transformation usually can be right like this. Suppose I change coordinate from R to R prime. They are related by a rotation matrix R. Say X prime, Y prime, Z prime is equal to R times X, Y, Z. Here R is a 3 by 3 rotation matrix. So if I write E prime as R times E and the D prime be written as R times D, okay, then I can derive this relation from this relation. I just multiply the R matrix from left to the first equation. R D is equal to R epsilon E. And I can write this as R epsilon R inverse R E. Okay? And R times D is nothing but D prime. And R times E is nothing but E prime. Okay? So if you want to keep the form unchanged like this, you must identify epsilon as R epsilon R inverse. Okay? 这个 R 是所谓的 rotation matrix. This relation tells you how to change the components of epsilon when you do the coordinate transformation. Okay. 好，那所以这边的话，你就可以看得出来，这个 epsilon 这个矩阵在坐标转换下是怎么转换的。This transformation in linear algebra is called similarity transformation. This transformation this transformation epsilon prime equal to r epsilon r inverse. This is called similarity transformation.相似变换，对不对？相似变换。If we do the similarity transformation properly, we may make the epsilon prime diagonal form. OK， 好，就是说我们可以经由相似变换，把 epsilon 变成一个对角的形式。那个情况就是相当于什么东西呢？相当于在解 eigenvalue， 好，相当于找到这个所谓的主轴系统。好 ，You have learned in linear algebra that we can do linear transformation to diagonalize the matrix. So you can choose the proper R matrix so that finally we get an diagonal form epsilon prime. Okay. So once you get this kind of epsilon matrix, you find the so-called principal axis system. 就主轴系统。So what is principal axis? Principal axis is in fact parallel to eigenvectors. .任何一个主轴就平行于某一个 eigenvector 就是说所谓的主轴就是主轴的意思就是 eigenvector 的方向就是 eigenvector 方向。The direction of principal axis is the direction of an eigenvector, and in fact we have three principal axes. Any two of the principal axes are orthogonal to each other. 就是两两垂直两两垂直两两垂直。So if we choose the principal axis as our coordinate system axis, the axis of our coordinate system, we choose the coordinate system properly so that we have three axes just along the eigenvectors directions of this original epsilon matrix. Then in this proper axis, principal axis coordinate system, we get the epsilon of this form. The diagonal form. OK， 好，就是说，我们如果选择了这种很特殊的坐标轴方向，好，我们可以大大简化问题Use this principal axis system, we can simplify the representation of all physical quantities because now we have epsilon be having the diagonal form. 我们现在这个 epsilon tensor 的矩阵就具有对角形式就具有对角形式。这边我要讲一下那个课本上有个公式错了有个公式错了就是说这边你看我讲两件事一个 跟课本的公式有关哈。Now you see in the textbook, the formula is written like this. 这是正确的啊。Like this. This is correct. This is not incorrect because here we see that this equation is written without the summation sign 啊，没有这个累加的符号。But you see that here we have repeat index 好，什么意思呢？就是说，这是爱因斯坦的发明的哈。This form is called Einstein convention 啊 because Einstein when he started the so-called general relativity, he encountered a lot of calculation, tensor times tensor, tensor times tensor, and sum over the indices. And he found a way to get rid of this complicated calculations. He found that when we encounter repeated indices, we can safely ignore the summation sign and to simplify the expression 啊，就是爱因斯坦发现说，反正我们常常要做这种指标相同的运算啊，就指标相同，遇到相同的这个东西都是要加起来的，所以他就给一个规则，的规则就是什么呢？就是你只要遇到指标相同就要加起来。那这时候你只要遵守这规则，就不用写这个累加符号，就可以简化这个表达式。好，那这种表达方式就叫爱因斯坦 convention。好，就是说 ，so Einstein invented this convention so that we can simplify the expression without writing too many summation signs。啊，不用写到这么多的 summation sign， 所以这个公式是正确的。好，但是呢，有一个情况是要小心的，就是万一你遇到是3个东西乘在一起，然后要重复指标的时候，那就不能这样用啊，因为这时候会产生错误啊，会容易错误啊，所以这种情形仅限于2次重复的，好，就或者是应该说叫做重复1次啊，就是说 repeat once you can use this convention, but repeat twice you must be very careful. Sometimes we encounter some quantity look like epsilon ij times ej, but do not sum the j. Then you write no sum. Okay, no sum means that 就那个遇到那种情况的时候，我们就不能够使用所谓的爱因斯坦的偷懒方法啊。那爱因斯坦自己说，他对数学最大的贡献就是发明了这个偷懒的方法啊，爱因斯坦 convention。Okay, and there is a relation between epsilon and chi. So epsilon ij, since d is epsilon 0 times the identity tensor plus chi tensor times E. So in component form, we can write this as di is epsilon 0 times delta ij plus chi ij times ej. Okay, so we have epsilon ij equal to delta ij, epsilon 0 times delta ij plus chi ij. OK， 在课本的公式里面的这个公式写错了哈。In textbook 4.1-5, in the textbook here the author write this as 1. which is incorrect. You modify it to delta ij. Here delta ij means Kronecker delta. Here delta ij is this notation. It is equal to 1 or 0 if I is equal to j, if ij are different. Okay, this notation is called Kronecker delta。这是一个符号，这符号就是用来表示一个这样的状况哈，就 ij 相同时候是1，不同是0哈，因为这是单位矩阵嘛，单位矩阵就是对角分量是1嘛，非对角是0，好，那对角分量就是 i 等于 j 的情况，啊，就 i 等于 j 的情况哈。So in matrix form, the I tensor is just the unit matrix. So according to the unit matrix has the diagonal element all equal to 1, and the off diagonal element are all to be 0. OK， 好，所以在这个单位矩阵的时候呢，就是属于这样的状况。所以我们取出分量来看的时候，就是这个情况啊，这叫 Kronecker delta 啊。所以课本的4.1至54把它改过来。Another thing to say about the epsilon ij is that epsilon ij is in fact equal to epsilon star ji. In general, we have this relation. If the medium is non-absorptive， 啊，就是就是说，你一个材料如果它本身它不发热的话，啊，它没有吸收的机制的，没有 damping 的机制的话，那 epsilon ij 跟 epsilon ji 会有这样的关系。啊，那如果它是刚好实数的时候，它就会是一个对称矩阵；如果它是 complex 的时候呢，它会是一个所谓的 Hermitian 矩阵。啊 ，This means that in matrix form, epsilon is equal to epsilon dagger. Here the notation dagger means two operations. First, transpose, and the second operation is a complex conjugate. OK， 好，就是说这个的意思就是 transpose 在 conjugate. You do the transpose of the original matrix followed by a complex conjugation. Okay, this combined operation is called dagger. Okay, when epsilon is equal to epsilon dagger, we call this matrix Hermitian matrix. Hermitian matrix has the property that all of his eigenvectors are orthogonal to each other, and all the eigenvalues are real. 好，就厄米矩阵的特色就是它的所有的 eigenvector 都两两正交，然后它的 eigenvalue 都是实数，好，都是实数啊。 就这样啊。那当然我们实际真实的物体啊，真实的材料呢，其实还是会发热，还是会吸热，所以它会稍微偏离这样一点。但是我们假设它偏离的量非常少，至少在我们光学问题的处理上，我们可以把它当成它是 Hermitian。好。About this property, if you want to know the details, you may refer to this. Ah, 你们可以去看 Feynman Lecture on Physics, Volume 2, Chapter 31 啊，它大概看到31之1大概就可以。好的 ，the first section of Chapter 31, Feynman give you an argument about for the real axiom. It has this symmetric property. Okay. And according to this symmetric property, for real axial matrix, this is so-called symmetric matrix. Real symmetric matrix. For real symmetric matrix, this is the special case of the Hermitian matrix, and you will get the result I mentioned about the orthogonality of the eigenvectors and the reality of the eigenvalues. OK， 好，就是它的这个 eigenvalue 是实数，然后 eigenvector 是正向，好。好，所以这边关于它的这个对称性的这部分，我们就不 follow 这个课本上的写法，因为课本上的写法其实逻辑上是有漏洞的啊。The argument in the textbook about why the epsilon ij is equal to epsilon ji has some logic bugs. Okay, so I recommend you to see Feynman lectures on physics. Now we begin to study the propagation properties of the electromagnetic waves in anisotropic medium. We try to study a plane wave propagating in anisotropic medium, and we assume we use the principal axis system to represent the epsilon tensor. Okay, so consider a plane EM wave. Suppose the angular frequency is omega, and wave vector is k. So we try to represent the E vector, E field, as say E0 times exponential I omega t minus k dot r. And h is h0 times exponential I omega t minus k dot r. So now I want to study now I want to study the practice of the polarization of this EHD vector. And also I want to know the relation between K and omega, which means that I want to know the refractive index. OK， 好，我们想要知道这个折射率。好，when we consider isotropic medium, the relation between K and omega is very simple, and the refractive index is direction independent. 啊，就说你不管往哪个方向传，它都一样。啊 ，when you consider isotropic medium, the refractive index has nothing to do with the propagation direction or polarization direction. However, in anisotropic medium, you will see that the refractive index is direction dependent. Okay, it is determined by the polarization direction and the propagation direction. Okay. So, how to derive the relations between omega and K? So, we have the Maxwell equation. We have the Maxwell equation. First, the divergence D is equal to 0 because we do not apply any free charge, okay, to the medium. And we have divergence B equal to 0 because there is no magnetic charge in the universe. Okay. And we have the Faraday's induction law, which relate the time-varying magnetic field to the special varying electric field. Okay. And finally, we have Ampere's law without the current. This is equal to partial T, which describes how the time-varying D field generates the special varying H field. OK， 好，那我们下一堂课再来研究这个内容。好，我们这边先下课一下。